So we are in lesson 7 or 5-4, so chapter 5, lesson 4, and we're going to actually do this over 2 days. And I have to admit that the second part we're going to do tomorrow is what I part of what I did on Friday. By the way, happy Pi Day, 3.14. And so we'll just do a little review of that since not too many people remember what we talked about. Okay, so first off is we have a new vocab word, polygon. So we're going to add that to our notes. So this would be a new card you would be making, or on Quizlet, a new definition to add. And a polygon, poly meaning many and gon meaning angles, is a simple closed figure formed by 3 or more line segments. So those line segments would play the role of the sides of your polygon. And the line segments intersect only at the endpoints. Now, I called the endpoints a different name. Do you guys remember what they were called? Where the two endpoints meet? What's that called? Vertex, okay? And when I pluralize it, it's the vertices. Now, what they aren't telling you is that there's two different kinds of polygons, and they're describing one type. And again, you're going to get more into this when you're in your geometry class at the high school. But we have two different kinds of polygons. One that meets this definition, and that's called a convex polygon. And then there's another kind of polygon called a concave. So convex, you don't have to write a vocab word on this one, just to give you some information. Let's draw this one. So all of the segments meet at endpoints, forming vertices for your polygon. But concave, people remember it kind of caves in on itself, so a lot of times it's a shape that might look like this, where it caves in, okay? And then what it was describing is that the segments intersect only at endpoints. It might look like something like this. There's an intersection in between, so right here in the middle of this kind of hourglass shape, that would make it not convex. Now, the problem with concave is I can't really calculate very well with them. So all the things that we talk about for us in this geometry portion deal with things I can have numerical values for, things that I have formulas I can use. So we're always talking about convex polygons. Okay, so we'll get into them. Now, I did notice in the book that they do use some named polygons with the assumption that you already know what they are. So I want to just review a couple of the big ones, meaning the most common ones. Oh, by the way, according to that definition, would a triangle meet the definition of a polygon? Yes, because it says 3 or more sides. So a triangle is one. Now, what's interesting is the name for four-sided figure. A lot of you go, square. Well, that's not the only four-sided one. Rectangle. That's not the only one. There's actually 5 different four-sided figures that get studied. We have squares, rectangles. We have, actually 6. Parallelograms, forgot about them. Trapezoids, we've got rhombus, and then we have a kite is another one. Okay, commonly in your minds called a diamond, but it's not really that. Okay, it's a kite. And so we do have a generic name that means any four-sided figure. Does anyone know what that is? Jenny? It's a quadrilateral. So I'm going to list out some names here. Quad meaning 4, lateral meaning sides, quadrilateral. So that's a four-sided figure. And figure is just another name for shape. And then, do you guys remember what a five-sided figure is? Nope, it's not a five-agon. Nice try, Jenny. It's a pentagon, just like the military building in the DC. Penta meaning five, gon angles or sides. So here's something maybe you haven't put two and two together, but the number of angles that a figure has mirrors the number of sides it has. A triangle has three sides, but it also has three angles. A quadrilateral has four sides, but it also has four angles, and so on. Oops, that's not the word figure. And so he can be in any kind of orientation, but that's a common five-sided figure there. And then six-sided figure is a hexagon. So that's a six-sided figure. A lot of people think of honeycomb, or if you think of nuts and bolts, that's the nut that, and inside would be a circle, and that's where the screw goes through. Next one is the stop sign, which is an octagon. So again, these are the most familiar ones. But the one that is mentioned that a lot of people aren't as familiar with is the decagon. But you could relate it back to a decade, starts the same way. Okay, and how many years are in a decade? 10. So this is a 10-sided figure, and I will not even attempt to draw that one. After an octagon, I pretty much am terrible at drawing. In our book, once it goes beyond 10, a decagon, they just call it an 11-gon, a 12-gon, a 15-gon, and so on. So the gon meaning angles. But there are actual names. I used to make my kids memorize up to 13-sided figure, which was a triskaidekagon, because I thought it was just a funny name. Yeah, it's a dodecagon, and then 11 is it's either a hendecagon or undecagon, depending on how you want to say it. Yep. Did it? So, here's what we're going to do. We're going to explore about polygons and their angles. So since we already know how many measures, the angle, what they measure in a triangle, we're going to see if we can figure it out for other shapes. So we're going to create a little chart. Our chart is going to have 4 columns. So the columns are going to be number of sides, sketch. So we're going to actually draw a little picture. We're going to write down the number of triangles, because in our sketch we're going to see how many triangles can we create in our shapes. And then we're going to have the sum of the measures. And when we talk about angle measures, we're talking inside angle measures. So we're going to start off with the most simple shape that we've already studied and we already know the answer for. Oops, sorry. I put them in the wrong spot. 3 sides forms a triangle. How many triangles do we have in a triangle? 1. So we know that there's 180 degrees for each triangle. So a triangle measures, the angles measure 180 degrees for the angles inside. Okay, fabulous. So let's try a 4-sided figure. So I can sketch. Now again, it doesn't have to be any shape in particular. But my rule is when I want to figure out how many triangles that are inside my shape, I go from one vertex and I draw shapes, lines to other vertices. Now, they can't be adjacent vertices because, for example, if I try to draw one from here to here, it doesn't form a triangle, right? It's just a side. So it's got to be for non-adjacent vertices. So this one's non-adjacent. Okay? I only do it for one. So how many triangles did I split that 4-sided figure into? 2. So now I'm going to figure out what 2 times the measure of one triangle is going to give me 360. So what that says is all four-sided figures, all 4 angles add up to 360 every time. Okay? Always. Let's try another one. Let's do a 5-sided figure. So again, we'll draw one. And I'm going to pick one vertex. For some reason, I like the left top. And I'm going to just connect them to adjacent, not adjacent, but non-adjacent vertices. So I see one across here and one here. So it has to come from that one vertex. How many triangles did I just form? 3. So then that means I have 3 triangles inside of it. So I multiply 3 times 180, and I get 540 degrees. So all 5 angles add up to give me 540. Okay? Let's try a 6-sided figure. So that's our hexagon. And again, I'm going to pick one vertex, and I'm going to connect them to any vertice that's not adjacent to it. So here's one that's not adjacent to it. Here's another one that's not adjacent to it. Here's a third one. So how many triangles did I form on that one? I had 4 triangles. So I have 4 times the 180. And anyone can tell me that one? 720 degrees. So here comes my big question. What if I have n sides? Okay, so here's the question I want to ask you. Look at how many sides we started with, and look at how many triangles we ended with. 3, 1, 4, 2, 5, 3, 6, 4. Do you see a pattern between how many sides our shape had versus how many triangles we created? It changed by 2, didn't it, right? The number of sides decreased by 2, and that told us how many triangles. So when I can't draw a picture of an n because I don't know what n means, it's any number. So what I am going to use, though, is that pattern that Sean just said, is my number of sides decreases by 2. That's how many triangles I have. So if I want to figure out how many degrees all the angles inside my shape equal, I'm going to take the number of sides minus 2 and multiply it by 180. What we've just created is a formula that allows us to figure out the number of degrees inside of any polygon, any size. Okay? So, all right, are you guys good? Okay. Oh. So this is basically got a name, another flashcard, interior angle sum of a polygon. This is its fancy name. And what it says is the sum of the measures of the interior angles of a polygon is n, the quantity n minus 2 times 180, where n is the number of sides of the polygon. And they just wrote it out as a formula for us, where S stands for the sum of the interior angles is equal to the quantity n minus 2 times 180. So you don't have to memorize how many degrees are in each different sized shape. You can just use this formula to figure that out. So, okay. Now, what if I had a shape where everything was the same? So all the sides measured the same, all the angles measured the same. We have a name for that with polygons, and that's regular. A regular polygon is equilateral. That means all sides are equal in length. Zach, you're supposed to be taking notes. And equiangular. All interior angles measure the same. Okay, so a regular polygon is equilateral, with all sides are equal in length, and equiangular, all interior angles measure the same. Now you should have heard of equilateral in the past, but you may not have heard of the word equiangular. Okay. So why this becomes important if somebody says, okay, I've got a regular polygon that has 10 sides. What's the measure of each angle? That's the only polygon I could do that with. Because if I had just a polygon that had 10 sides, all the angles could be different things. I couldn't figure it out. So when we have something that's predictable, all the sides are the same, all the angles are the same, then I can actually do math. So let's see if we can squeeze in one quick example. And we have a, find the sum of the measures of the angles, the interior angles of a decagon, a regular decagon, then find the measure of each angle. Okay, so first thing we're going to do is find the sum of the interior angles. And we're going to use that formula, n minus 2 times 180. Okay, so how many sides does a decagon have?
10.
That's the one with 10 sides. So we're going to substitute in 10 into our equation. And we get 8 times 180. So let's see, I get a 0, I get a 64, and I get a 14. So I get 1,440 degrees. Okay, so that's the first answer they want. Okay, now I'm going to find the measure of one angle. So if they all equal 1440, and I have 10 of them, what am I going to do to figure out what one of them measures? Connor.
Divide 1,440 by 10.
So this is the total, and this is the number of angles. And the answer is, each angle measures 144 degrees. Okay, now, this was an easy one because the numbers were nice. It gets a little bit more complicated when we have different numbers, like a 15-agon or a 7-gon or something like that. So it is possible to get answers that don't work out pretty. And if you notice on that worksheet I gave you, it did tell you to round answers to the nearest tenth. So you may have that happen. This one, no, because it worked out evenly. So it's only if it comes in the decimals that you would do rounding, okay?